So what we have learned so far is about solving equations, rearranging formulas so we can solve for a letter or we can find the value of something. And we have learned about exponential law, the law of exponents, right? And basically it's all coming to writing exponential equations, okay? So an exponential relation are modeled by the exponential equation y equals a b to the power of x. So this is your exponential relation. Remember, I don't know if you guys remember quadratic, right? Or if you remember linear. Linear used to be y equals mx plus b. Quadratic can be any of these three, y equals ax squared plus bx plus c. But when we're talking about exponential, it's y equals a b to the power of x, where your exponent is the variable. So a and b are going to be numbers, and the exponent, which is x, that's going to be your variable. Now a is your initial value, okay? So what you're starting with. So let's say if we're talking about the a car, the price of a car, right? You bought a car for $10,000. That's your initial price, right? So $10,000 is your initial price, so that's going to replace A. And let's say the car is going to depreciate in price, let's say by 20% every year. So that is going to replace B. Okay? So A is going to be your initial value. And B is called the growth or decay factor. Sometimes you're going to have a growth factor, sometimes you're going to have a decay factor, depending if you have an increase or a decrease in your exponential function. Okay? So if B, which is your base, is greater than 1, then you have exponential growth. And if B is less than 1, so technically it's going to be between 0 and 1, it's not less than 1, so I'm going to put between 0 and 1. So it's at 0.5, 0.25, 2/3, you know, all these numbers. It's going to model an exponential decay. Okay? So it's going to be decreasing. Now, that B, two different kind of functions. So we have this, and we have this. Okay? What these represents, this is your exponential growth, and this is your exponential decay. Can you guys tell me what's the difference between the two? One is a plus, one is a minus, right? I is your rate. So let's say if your car is depreciating by 20%, right? Depreciating means it's decreasing, right? So which formula am I going to use?
Number 2.
The bottom, right? It's this one. And then A is going to be 10,000 because that's my original price, right? And then 1 minus 20%. 20%, that means 0.2. That's I. Yeah. Right? So it's going to be decreasing, that's your rate, by 0.2. So basically, if I'm following whatever I just said, so the initial price of the car is $10,000, right? And then it's depreciating by 20%, right? My formula is going to look like this, or my equation is going to look like this. Y equals 10,000, 1 minus 0.2 to the power of x, right? Because 20% is 0.2. Make sense so far? So if I want to put this together, that's going to be y equal 10,000 and then 0.8 to the power of x, right? So what's your initial value?
10,000.
What's your base, b? 0.8. Can you guys confirm that 0.8 is between 0 and 1? Yes, right? 0.8 is a value between 0 and 1. And we said that any value between 0 and 1, it's going to be decay. Makes sense, because the price of the car is depreciating. That means it's going to be decreasing. Does it make sense to what's going on? So we're going to have two types of questions. A type of question where it's going to give you a rate, and then you're going to have to use one of these two formulas. Okay? And if it's going to be depreciating, that means you're going to use the second formula. It's going to be increasing, then you're going to use the top formula. And another kind of examples is going to be, let's say they say doubling, right? Or if they say the thing is half, right? That means right away you're going to replace your base with either 2 for doubling or a half for half length. Okay? We're going to talk more about these kind of functions later on. Okay? So, let's read the first question. A city will be modeled by the equation P equals 1.4 times 1.04 to the 15 to the power of T, where P represents a population in millions T years after 1985. In which year did the population first exceed 3 million?
So there would be an increase.
So it is an increase, and how do we know that it's an increasing?
Greater than 1.
What's greater than 1?
B.
The base, right? So your base right here, which is 1.0415, right? That is your base, and it's greater than 1, so we know that's an increasing function. That's great. Good. Now, my question to you is, what is your beginning population? What's your initial population?
1.4 million.
1.4 million. What's your ending population? What is the question asking you for?
3 million.
When it gets to 3 million. So the time when it gets to 3 million. So your end population that you're looking for is 3 million. The population is growing at a rate of what? What is the rate that the population is growing at?
1.0415.
Now that 1.0415 is not your rate. The rate has to be percentage. Okay? So if I go back here, this equation is similar to which one? The top one? The top one, right? Because it's 1 plus something. It's higher than 1. It's an increase, right? So it represents the top. So the 1.0415, that is equivalent to 1 plus I. Do you guys agree with that? Yeah? Okay. So 1.045 or 1.0415 is equal to 1 plus I because I have an increase in the population. So what would I be?
0.0415.
That's right, because I'm gonna, right? So it's gonna be 1 minus 1.0415 minus 1. So it's gonna be 0.0415. So what is that in percentage? If I multiply this by 100, it's gonna give me 4.15%. I know it's an increasing function because my base is greater than 1. So I took the base, which is 1 plus I equal it to whatever the base is equal to, and I solved for the rate because I don't know what the rate is. I have to solve for it. Are we okay with that? So that means the population is increasing by 4.15% every year. Are we okay with that so far? All right. Now the question is asking you to solve for t when the population is 3 million. Yes? That's what the question is asking you? All right. So where would I put that 3 million? So this is the equation. Where would you put that 3 million?
P.
For P. In this case, yeah, Y, which is in this case, it's P. Right? So I'm going to replace P with a 3. Now, how would I solve for that T? What's the first thing that you want to do? Get it by itself. How would we do that?
3 divided by 1.4.
That's right. The first thing you want to do is you want to get rid of that 1.4, right? So you're leaving kind of this by itself, the 1.0415 to the power of t, right? So you want to bring this over, and then that will be 3 divided by 1.4 is equal to 1.0415 to the power of t. Can you find what 3 divided by 1.4 for me, please? Sorry? 2.14, 2 more.
2.829.
2. Okay. Now I need to solve for that exponent t. How would I do that? How do we learn that? Huh? Make it the same base. And how easy is it to make it the same base because I have decimals? Not easy. So if I have something like 2 and 32 or 2 and 16, it's easy to make it the same base, which we learned on Friday, right? But in this case, because I have decimals, it's not that easy. So the only way I can solve for t right here is, for now, is doing trial and error. Okay, so start plugging in values for t, right? And then do 1.0415 to the power of whatever number you're gonna think of, okay? Do that until you get as close as possible to 2.1429, okay? You can start with small numbers, but then you're gonna see that these small numbers are not going to help. So you're gonna have to include a little bit higher numbers, right? So, did you try any numbers? What numbers did you try?
18.744.
You got 18.744, and that gave you the exact value. Okay, how about 18? What did 18 give you?
2.079.
So if you do 18, sorry, just one second. What did that give you? The 18?
2.079.
2.079. Okay, how about 19?
3.165.
2.165. Good. So, in order for, because the two, like this is above 2.1429 and this is below 2.1429, so I'm gonna guess that it's between the 18th and 19th years. You're not going to find the exact value when you're doing trial and error, okay? So it's going to be a range, something like, two numbers, and it's somewhere between these two numbers. Should have wrote this. You guys can write this right under here. Okay? Now, I didn't do too many trial and errors. You guys are going to be doing more trial and errors than me. The reason why I didn't do them because you already told me what they are.
Why did we have to do this then? And not put it in here and we get 3?
You can, but then it will be more work, right? Instead of just entering 1.0415 to the power of a number, right? You have to multiply by 1.4 and then just isolating first. You know? And then you'll see why later. Okay. All right, so if I'm talking about between the 18th and 19th year, right, that means I remember that this formula is since what year? After what year? 1985, right? So what's 18 years after 1985? How do you find that?
1985 plus 15?
Yeah.
2003?
So you're going to say that between 2003 and 2004. The population will be about 3 million. Are we good? So whenever you're solving for an exponent, at least as for now, whenever you're solving for exponent and you can't make the bases the same, you probably want to do trial and error to get the answer. Okay? Okay. Remember I said there's two cases basically that we're going to look at. If the question gives you percentage or rate, we're going to use the two formulas that I talked about, which is the A1 plus I to the power of n or x or whatever, and then A1 minus I to the power of x, right? So this is one case where if I have a rate. The other case would be if I have doubling or half-life. Okay? So the question would be telling you that you have, let's say, bacteria, count of bacteria starting with 100 bacteria, and then they're doubling every 5 hours. Okay? So right now, when you read the word doubling, you're going to have to think about this type of equation. Now, A naught or A0 is the same thing as little a. It's your initial value. Okay? They write it as A naught. There's different kind of, like they can write it whatever they want to write it. It's going to be the same thing, right? But I'm going to use this one, and I think I have it here for you guys, and follow the same letters. Okay? Maybe the formula sheet is going to have it in a different, with different letters. I don't remember what the formula sheet is. I don't think even the formula sheets have it. No. Okay? So, A0 is the same thing as small a, or A naught it's called, and it means it's the initial amount. Okay? 2 is your doubling, and it's doubling, and that's why it's at 2, because it's doubling. A is your final amount. T is time measured or calculated, so that's a T on top. Now, D is your doubling time. So let's look at that. That's new. D is new. D is your doubling time. Which means doubling question. So you have 100 bacteria, and it's doubling every 5 hours. How many bacteria will you have after 8 hours? Okay? So let's start assigning the numbers to the letters. Okay? What does 100 bacteria, for what letter is it going to be replacing? What letter is it going to be? It's A0, right? So that's your initial value. So you're starting with 100 bacteria, it's going to replace A0. So A you're looking for, you don't know what A is. You're replacing it by 100. 2, because it's doubling. Okay. It's doubling every 5 hours. That 5 hours is your doubling time. So what letter is it going to replace?
D.
D. So that 5 hours represents D. Now, the question is asking you how many bacteria you will have after 8 hours. So what do I do now? Replace T with what? With 8. Because T is my, sorry, I should have wrote 5 here. And now I can enter it into my calculator, right? Remember that when you enter it in the calculator, you're going to have to put 100 bracket 2 bracket power open bracket 8 divided by 5 close bracket. This is a power. What do you get?
303.14.
So 303 bacteria?
Yeah.
Does it make sense? Does it make sense? That's my question to you. Yes, it does. Why does it make sense? Think about it this way. You're starting with 100. After 5 hours, you're going to double. So how much you're going to have after 5 hours? 200. Now, after 8 hours, right? So that's 1 double and a bit more, right? Because 2 doubles would be 10 hours, right? So it has to be more than 200, but it has to be less than 400. Because double of 200 is 4. Right? So at 5 hours, I'm going to erase that. At 5 hours, you're going to have 200 bacteria. At 10 hours, you're going to have 400 bacteria. Right? At 15 hours, you're going to have 800 bacteria. Right? 8 hours is between the 5 and the 10, so it's going to be somewhere between 200 and 400. So your math should make sense. So a lot of students, they don't know when I ask them, what is your doubling time? They wouldn't know how to answer that because they don't understand the question. Okay? So your doubling time is how long is it taking for your initial to double? Okay? And usually it's given to you in the question. Right? And it says it doubles every something. Okay? Now, the equation of the half-life, so it's the same idea. You're doubling, that means you're increasing. Half-life, that means you're decreasing. Okay? So you're starting, let's say, with 100, and then every, let's say, whatever, 5 hours, you're losing half. Okay? So the function would be a equals a naught 0.5 t to the power of t over h, where h is what? The half time. So the question would be saying, like, it's you're starting with 100 bacteria, and then you're losing half of it every 5 hours. Okay, so same idea. H would be 5, and we're gonna solve A naught will be on. Are we okay with this so far? So far today we learned 4 equations, right? The 1 plus I, the 1 minus I, the doubling, and the half. Now, I'm just going to introduce this quickly because this kind of saves time if you know how to use it. Remember how in the previous question we had to do trial and error to find that t value? There is a way that we can use our calculator to actually solve it without doing trial and error, and it will give you the exact value. And it's called logarithm. It's not part of the curriculum for grade 12C, but it will be something useful. You might use it, you might not use it. You know, it's just something that I can introduce to you. So, if I'm solving for that exponent x, I can actually solve for it by doing log of y over log of a. So on your calculator, you're going to see a button that says log. The log button. Okay? So, let's look at it. So you have y equals a to the power of x. You're solving for x. So what you do log of y over log of a. So looking at the first example right here, so 5 equals 1.06 to the power of x, how would you solve for x?
Log of 5 or log of 1 plus 0.6.
So it will be log of 5 over log of 1.06, right? So x would equal to log of 5 over log of 1.06, and you get what?
0.62.
So, I did not have to do any trial and error, right? I did not have to waste time. I just had to use the formula and use it correctly to find the answer, and then the answer is exact.
So does that work for like all of the questions we did
Previously? Yeah.
Sometimes I would, you can check your answer, yes, for sure, but sometimes I would want you to do it. If it's doable by doing same days, you probably want to do that first. Okay? You can check your answer using this. Okay?
But for in case we have a decimal. we can
In the
use-
case of things you have a decimal, you can use that. Okay. Okay, now help me with the next one. What would I do?
Log of 25 over log of 0.97.
And that would equal to what?
Power of.
What would that equal to? Would that equal x? What would it equal?
2x.
It would equal 2x, right? So it will be 2x equals log of 25 over log of 0.97, right? Now find the answer for that. Negative 1.
5, 1.
Okay. Yeah?
Got more decimals back there.
That's fine.
Yeah, same thing.
Okay. Now, if I want to find x, this is not my final answer because this is 2x. If I want to find x, what do I do? Divide by 2. So x equals to negative 1.05, sorry. Use the wrong point. Negative 105.6 divided by 2. So that's going to be negative 52 point what?
8.
8. Okay, try the next one. Okay, so for this one's going to be x over 3 equals to log of 120 over log of 0.97. What's log of 120 over log of 0.97?
Minus 157.18.
120. Okay, now what do you do to find the final answer?
Multiply by 3.
And the answer is going to be what?
471.5.
Are we okay with this? All right. Are we good? Caffeine has a half-life of approximately 5 hours. Suppose you drink a cup of coffee that contains 200 milligrams of caffeine. How long will it take until there is less than 10 milligrams of caffeine left in your bloodstream? So, caffeine has a half-life of approximately 5 hours. Suppose you drink a cup of coffee that contains 200 milligrams of caffeine. How long will it take until there is less than 10 milligrams of caffeine left in your bloodstream? So what kind of question is this? Half-life question. So what formula am I going to use?
A equals to AO 0.5 T over H.
Good. Now let's start filling out the unknowns. So what do I know?
Your initial value.
Sorry, which value?
Your initial value.
What's my initial value?
200 milligrams?
200 milligrams, right? That's what I'm starting with the way I drink. Good. What else do I know?
You know, it's about 5 hours.
So which one is, what would I replace? What letter?
H.
H. H is
5.
H half.
Okay.
You guys have to be careful with that. And this is where the mistake happens. They think it's T. It's not T. Because it's half-life of 5 hours. So it's going to replace H. What else do I know? How long will it take until there is less than 10 milligrams of caffeine left in your bloodstream?
So you know 10 milligrams. So you do the
So
half.
10 milligrams is final amount, so it replaces the letter A. So what letter am I looking for?
T.
T. And you see why we do that now? Because you can use log, right? So in order for you to use log, you have to isolate first. So what's the first thing I want to do? Divide by 200. So 10 divided by 200 equals to 0.5 to the power of t over 5. What's 10 over 200?
0.05.
Okay? Now, you can do trial and error or
Log.
log. So how would I do log? What would it be? Z over 5 equals
Log 0.0.
Log 0.5 divided by log 0.4.
log of 0.05 divided by log of 0.5. So what do you get for the log? 4.32. And then what do I do to solve for t?
Nice.
So what do I get? And that is hours. And then you're gonna have to give me a better for statement. So after, you need about 22 hours for the amount of caffeine to be below 10 milligrams. So, read the question, ask yourself if it is, what kind of equation it is going to be. Write the equation down, right? Write the formula down in one of these four, write it down. And then start filling in the values that is given to you. And then make sure that you know what you're solving for. Okay? Now the question to you, I'm gonna ask you a question. If the question is asking you, how much caffeine would you have in your bloodstream after 1 day? What do you do?
You do 5 hours to 24 hours.
Change the 1 day to hours. That's very important. Because the bottom right here is going to be in hours, right? It's divided by 5 hours. You have to match. They have to have the same unit, right? So my T has to be in hours. So instead of 1 day, I'm going to replace it with 24, right? And then I'll be looking for A, right? Because how much caffeine do you have left in your bloodstream after 1 day? So it's going to be 200 bracket 0.5 bracket to the power of 24.
That's if the question asks for approximately 1 day instead of 5 hours.
No. The 5 hours is not changing.
Right.
The question changed. Instead of asking you how long will it take until blah blah blah,
Yeah.
the question is asking you how much caffeine do you have left after 1 day. This part did not change. Does it make sense? Now, why did I ask this question? I want you guys to understand that you can't have, so T and H, they have to have the same unit. If H is in hours, then T has to be in hours. If H is in days, then T has to be in days. Are we okay with that? Alright, so technically that is the end of our unit. You guys can work on finishing the homework questions for today. And you also have review. I know I did say that we might have a quiz tomorrow, but I don't think I want to do a quiz tomorrow. Tomorrow is just going to be basically review questions. I can take up any questions that you guys have from the unit or from the review, and then we'll have a test on Thursday. Okay?
So we have 2 initial quiz coming up? Or is
Sorry?
that tomorrow? So we have 2 initial quiz that were coming up? But you said the quiz was
I
not
said
coming
there's
up.
no quiz. That's what I said. I said we were supposed to have a quiz, but we're not having one. We have a test on Thursday.
Okay.
Okay?